in calculus, it's going to be very important for us to be able to solve inequalities. And so we want to look here at solving some nonlinear inequalities. And I chose this one, number 7, from your worksheet to look at as the example. Remember making sign charts in pre-calculus? Well, that's where we're going to go with this, but we've got to get it into the format that we want first. In order to make a sign chart, we always want one side of the inequality to be 0. So we're going to start off there, and let's just subtract the left side. So we have 2n plus 1 over 3n plus 1 minus n minus 1 over 3n plus 1. And that is less than or equal to 0 then. Be careful. Note that the negative needs to distribute through here. And so we're going to distribute that through the top. So we're going to have 2n minus n is n, and then 1 minus negative 1. So 1 plus 1 is 2 over the common denominator we already had of 3n plus 1, and is less than or equal to 0. So at this point, we're going to look at, remember, the critical values. So critical values are what makes it equal 0 or be undefined. So that's when n plus 2 equals 0, or n equals negative 2. It's our first critical value. And when 3n plus 1 equals 0, that would be n equals negative 1/3, would be our second critical value. Okay, here's where we start the sign chart, and I like to do my sign charts. We're going to put the negative 2 on kind of a number line looking thing, and a negative 1/3. So I like to put up here, okay, that means this is representing the interval from negative infinity to negative 2, and from negative 2 to negative 1/3, and negative 1/3 to infinity. Along the left side, get rid of just a little bit here, I want my two expressions that are part of this whole thing. So that's the n plus 2 and the 3n plus 1. And then we have the quotient of those two. And now we go through and pick values within each interval to test this. So from negative infinity to negative 2, I'm going to pick something in that interval, let's say negative 10. So if I put negative 10 in for n, for this first expression, I'm going to get a negative. That's all I care about. Into 3n plus 1, I'm going to get a negative again. When I divide those, that result will be positive. Between negative 2 and negative 1/3, well, the nicest number probably I can get in there would be a negative 1. So if I put negative 1 into the n plus 2, I get 1, so that's positive. And into the 3n plus 1 is going to be negative, and so the quotient is negative. And greater than negative 1/3, I'm going to try 0, is positive and positive, so the whole thing is positive. We often see this alternating positive negative pattern, but not always. Be careful. Don't just assume that that's going to happen. So we were looking for when this was less than or equal to 0. I erased that earlier. So that means our solution is going to be from negative 2 to negative 1/3 inclusive, because we want to include the endpoints to make it equal.